want to dig a little deeper into ratios using unemployment rates. It's kind of depressing, but we're going to do it anyway. So we're going to start with our graph, and I really want to just take this first moment to talk about what this is. So if you look at our vertical columns here, this gives us the educational attainment, right? So we have less than a high school diploma, a high school graduate or equivalent, some college but no degree, an associate's degree, bachelor's, and then advanced. So that's across the horizontal axis there. And then down yonder, we have the civilian labor force. So the number of people in that educational attainment that are available to work, this is in thousands. The next row is unemployed. So how many people in that particular educational attainment that are unemployed in thousands? And then the last row being the rate. So the unemployment rate is a ratio of the number of unemployed to the number in the civilian labor force. So we would go unemployed over the civilian labor force for each educational attainment. So is this part to part or part to whole? And the answer is part to whole, because this denominator is all people in the civilian labor force for that particular group. So therefore, the units that should be in this last row, we need to add a percent to that because it's the employment rate. And if we have part to whole, we can write it as a percent. So let's go ahead and do that. We're going to add the units and calculate the last ones. So for the first ones where they're already giving us the numbers, we're going to add in the percentages. Now let's calculate the last two. So to calculate the unemployment rate, we're going to take the unemployed over the civilian labor force. So for bachelor's degree, 1274 over 36408. And because both of these numbers are in thousands, we can just divide and we're golden. So we can say, all right, we've got 0.03499. So we're just going to round that, multiply by 100, to 3.5%. And then for advanced degrees, we'll take 140 over 6,987, and that gives me 0.20200. So again, multiply by 100 to change it to a percent, and we're at roughly 2%. So now let's move on. Let's consider the values in the civilian labor force row of the table. Could we approximate the total number of civilians in the labor force? So we're talking about this row here. Can we figure out the total? And the answer would be yes, because we can add all of these together and that would give us the approximate. So if we add them all together, we would end up with 143,992,000. So 143,992,000. So that's how we could approximate the total number of civilians in the labor force. Now, part B, calculate the ratio of people with some college, no degree, in the labor force to the total civilian labor force. Okay, so we're going to go some college, no degree. So some college, no degree. So 3869 all over 143,992. This is part to whole because this top one, we're talking about some college, no degree, which is part of the labor force, to all of the labor force. And therefore, we could change that to a decimal by dividing and get 0.02686, which is roughly 2.7%. Let's use that in a meaningful sentence. So again, because it's part to whole, we can write that as the percent of 2.7. So what this means, of all people in the civilian labor force, 2.7% of them have some college, but no degree. So that's the idea. When you look about, if I would line up everybody in the civilian labor force, 2.7% of them would have some college but no degree. That's what that means. Letter D, calculate the ratio of laborers with associate's degrees to laborers of some college, no degree. Okay, so now we're talking about associates to some college, no degree. All right, well, we know, wrong way, my bad. Let's come back to our table. We know the some degree is 3869, associates is 3275. Okay, so associates, 3275. Some college, no degree, 3869. There's our ratio. Is this part to part or part to whole? Well, it's part to part because each one of these is part of the civilian labor force. So if it's part to part, that means we cannot write it as a percent. We've got to write this pretty much as a decimal. So if I divide 0.8464, I'm going to round that to 0.85. Now, when you think about a ratio and you're thinking about a meaningful sentence, as this last piece puts us, give yourself a fraction because this top number talks about associate's degree and the bottom is some college, no degree. So what does that mean? Well, it means for every one person with some college, no degree, there's my denominator, there are 0.85 people with associate's degrees. And you might say, well, that doesn't make any sense. And you're right, it doesn't. So sometimes we would say, well, if I have 0.85 over 1, if I move the decimal over one place in the top and one place in the bottom, it's basically like multiplying the bottom and the top by 10. I get 8.5 out of 10. So that means for every 10 people with some college, no degree, I have between 8 and 9 people with an associate's degree. And that is a little easier to see. We call this scaling up. It's a little easier because then you can picture 10 people. You can picture 8 or 9 people. You can't really picture 0.85 of a person. Now let's look at the same data, but in graphics, just to answer a couple questions here. So first, we're going to compare the graphs. They show the same thing. Across the horizontal axis, we have our educational attainment. Now, in the top, we have numbers. In the bottom, we have the unemployment rate, right? We've got the percentages. Okay, so why do the bars follow different patterns? And it's really important that you understand what these are the graphs are showing you. So in the top graph, as I mentioned already here, this is the number of unemployed. So when you look at just each category, when I have this category, this is how many people are unemployed. This category, this is how many people. That's just what it is. But when we get to the bottom one, where we're talking about the rate, now we're taking the number of unemployed over the total for that category. And then for the next one, we have the number over the total just for that category. So each denominator is different, right? The denominator is different. And because all of those denominators are going to be different, we're going to have a different pattern. And that's the idea that these are not relational based off of the denominators. I mean, that's the big idea of how are you finding these numbers. So because the total in the denominator is going to be different for each bar, that's why it matters. Okay, now the second question, what conclusions can you draw from these charts? Well, the first one might be a little more difficult, but you can see there are more people unemployed at the high school and less than high school areas, right? That's what the graph said. In the second graph, right, this is like more bars in more places here. But as you earn more college, so you gain more education, your unemployment rate goes down. And that could be for a whole host of reasons, but it's possible that the more degrees you have, you probably have more options, right? So if you only have some college, no degree, you might be great in one area. You've got specialized in one area, but maybe by the time you've gotten multiple degrees, maybe you now have 5 areas. So if 3 of them, aren't hiring, you still have options. So you have more availability for you. That's possible. I'm guesstimating there, but it does show that the more education you have, the less, I don't want to say the less likely you are to be unemployed, but the unemployment rate does go down. Okay, and that's a little bit about ratios and unemployment rates.